Solve problem 6.3. A trapeze artist starts his motion with the trapeze at rest at an angle of 45 degree to the vertical. The trapeze rope have a length of 5 meter. What is his speed at the lowest point of his trajectory? So here you have a trapeze artist who is starting his motion at an angle theta equals 45 degree with respect to the vertical. And at this point, which we will call as 1, he is at rest. So the speed v1 will be equal to 0. We need to find what is his speed at the lowest point in his trajectory. So which is this point, which we will call as 2. The length of the rope is L and the value of L is given to be 5 meter. So to solve this problem, we are going to use the law of conservation of mechanical energy. The law of conservation of mechanical energy says that total mechanical energy in an isolated system remains constant. That means if I have 2 points in motion, total mechanical energy at these 2 points has to be equal. So I can write total mechanical energy E at point 1 has to be equal to total mechanical energy at point 2. Now mechanical energy can be written as sum of kinetic plus potential energy. So E1 I will write as sum of kinetic K1 plus potential energy U1. And same with E2, we will write it as K2 plus U2. Now we will choose our coordinate axis such that at the lowest point in motion, the height at which the trapeze would be raised to would be taken as 0. So I can take height at position 2 to be h2 equal to 0. And the height at which it was initially raised at will be taken as h1. The total length of the string is L. So we write this as L. And I need to find what is the speed of the trapeze at point 2, which is the lowest point in motion. Since the trapeze starts at point 1, speed at point 1 will be equal to 0, which is the initial speed. So now let us write the expression for kinetic and potential energy. Kinetic energy at point 1 can be written as half mv1 squared, and gravitational potential energy will be mgh1. Same with point 2, kinetic energy will be half mv2 squared, and gravitational potential energy will be mgh2. Now we already determined that H2 is 0. So this quantity here, mgh2, will come out to be 0. Whereas speed v1 at position 1 is also equal to 0. So half mv1 squared will be 0. So we are only left with potential energy at point 1, which is mgh1, to be equal to kinetic energy at point 2. Cancel off the m and we get gh1 to be equal to v2 squared by 2. Rearrange to write in terms of v2. So we get v2 squared equals 2gh1. Take the square root. v2 will be square root 2gh1. So this is the expression for finding speed at the lowest point in motion. I just need to find what is the value of height h1. We know that total length of the string is L. And this is my height h1 at which the trapeze is initially raised at. Let the remaining distance be called d. So by looking at the figure, we understand that length of the string can be written as the sum of d plus h1. I want to find h1, so we can rewrite this as h1 to be equal to L minus d. We need to find what is d in order to be able to calculate h1. Now d is a side which is adjacent to the angle theta. So I can find d using cosine of the angle theta. We know that cosine theta is equal to adjacent side over the hypotenuse, which is d over L. So we get cosine theta equals d by L. You can rewrite d as L cosine theta. Substitute this in the expression for h1. We will get h1 to be equal to L minus L cosine theta. So let's substitute this in our expression for velocity here. We get velocity v2 to be equal to square root 2g L minus L cosine theta. Now let's substitute the numbers. 2g is 9.81. L here is given as 5, which is the length of the string, minus 5 cosine of the angle 45. And when you solve this, you get velocity of trapeze at the lowest point to be equal to 5.36 meter per second. So anytime they give you a question where you have 2 points and you need to find velocity at any one of the points, you will have to use the law of conservation of energy. And if this question has any swinging motion, like a trapeze artist, a swing, or a pendulum, you can find the height h raised from the reference point to be equal to L minus L cosine theta, where L will be the length of the swing and theta is the angle the string makes with the vertical. So you can directly use this value for h while solving problem like these, or you can always arrive here by using the steps shown in this problem.